There we go. Okay, so we're going to go over properties of parallelograms. So to start off, a parallelogram is a quadrilateral with two pairs of opposite sides parallel. Okay, quadrilateral meaning it has four sides. Its opposite sides are then parallel. Okay, and you can see that in the picture below. These arrows here mean those sides are parallel. These ones have two, meaning those sides are parallel. So I do have a chart here of the different properties of parallelograms. So your opposite sides in a parallelogram are congruent. Okay, so our opposite sides are congruent to each other. So if I look at the picture above there, I have opposite sides PS and QR. So I could say PS is congruent to QR. And my other opposite sides, I have PQ is congruent to SR. Okay, so those opposite sides are congruent. Our opposite angles in a parallelogram are also congruent. Okay, so here, if I say angle S, its opposite angle would be angle Q, and those two would be congruent to each other. So I can say angle S is congruent to angle Q. Same thing with P and R. Those two angles there are across from each other. They're opposite, so they are congruent as well. So we have angle P is congruent to angle R. Next, we want to talk about the consecutive angles. Again, those are angles that are next to each other. That's what consecutive means. So those angles are supplementary. You can write out supplementary if you want to. So my angles that would be next to each other would be like S and angle R. Okay? Those aren't congruent, but I can add them together. So the measure of angle S plus the measure of angle R would have to equal 180. Okay, that's just one example of that one. You could also take the measure of angle Q plus the measure of angle R, set them equal to 180, P and Q and P and S. Okay, so just each of those consecutive angles have to add to 180. Okay, our next property, if you have one right angle, then all angles are right angles, so they all equal 90. So if there's one right angle, all of them inside of a parallelogram will have to be 90 degrees. Our next property has to do with our diagonals. Okay, so if you were to draw in the diagonals from each vertice, they would bisect each other. Okay, so your diagonals bisect. So in my picture here, if I draw in both of my diagonals, they meet at this point. I'm just going to call it M, meaning diagonal SQ bisects diagonal PR. So each of these pieces will be congruent to each other. And PR bisects SQ, so I can say each of those pieces are congruent to each other. Okay? So I would have PM is equal to MR, and SM is equal to MQ. Okay, so it makes kind of that midpoint for both segments. Okay, the last one again has to do with your diagonals. It separates the parallelogram into two congruent triangles. Okay, so if you draw in one diagonal, your parallelogram is going to separate it into two congruent triangles. So if I were to draw in this diagonal here, SQ, I could say triangle SPQ is congruent to triangle QRS. Okay, so you draw in that diagonal, separates it into two congruent triangles. Same thing with diagonal PR, separates that one into two congruent triangles. Questions on these properties? Okay, we're going to use these properties then to solve for different sides and different angles within a parallelogram. So if you look at our first example here, if ABCD is a parallelogram, so we know it's a parallelogram, we want to find the value of each variable. Okay, so we want to find A and B. Well, A is right here, and it's alongside AB. Well, according to my properties of parallelograms, my opposite sides are congruent. So that means AB would be congruent to DC. So I could set those two equal to each other. So I have 2A is equal to 34. Divide by 2. A is 17. Then to solve for B, B is right here in my picture. And again, according to my properties of parallelograms, my opposite angles are congruent. Okay, so the ones across from each other, since they are congruent, I can set them equal to each other. Then all I would have to do is divide by 8. To get B is equal to 14. Okay, so you want to pick out those different properties of parallelograms and use them to solve for those variables. Okay, next problem, again, we're finding the value of each variable in this parallelogram. So each of these are parallelograms. So number 1, we need to solve for x and y. Solve for x. My x is right here. I know my opposite angles are congruent to each other. And I also know if one angle of my parallelogram is 90 degrees, then all of them are. Okay, so I can set 6x equal to 90. Divide by 6. And x is 15. Now I need to solve for y. Since this is a parallelogram, your opposite sides are congruent, meaning I can set those equal. So we have 8y equals 88. Divide by 8. And y is 11. Questions on the first two problems there? Okay, I want you guys to do 2, 3, and 4. If you're finishing up one of the problems, that's fine. I'm going to start going through them. So number 2, since this is a parallelogram, our opposite sides are congruent. So I can set 6x equal to 12, divide by 6 to get x is 2. Now each of these marks within my picture means all my sides are congruent. Okay, so I can also set 3y equal to 12 since those sides are considered congruent to get y is equal to 4. I think when I walked around, most people had that one done. Okay, then number 3, I have an x and a y. In both of these angles, I have an x value. Well, those are consecutive angles. Okay, they're next to each other. If I have consecutive angles, they do add to be 180. They are supplementary. So I can take 6x plus 12x and set it equal to 180. Okay, so I have 18x equals 180. Divide both sides by 18. And you do get x is equal to 10. Now in order to solve for y, I'm going to plug in 10 for x, my angle here. When I do that, I get 120 degrees. And I know that my opposite angles here are congruent. So now I know that this angle is 120. I can set 3y equal to 120. And then divide by 3 to get y is equal to 40. Okay, so don't forget about that property about your consecutive angles. Those ones are supplementary, they add to 180. Okay, the same thing goes in number 4. So I have to find x and y. Well, I don't want to set these two equal yet because they have different variables. Okay, but I do know what this entire angle is here. I can just add these two together. Well, that entire angle is 115 degrees. Now, with that angle and my consecutive angle, those both have to add to 180. So I can add 115 plus 5x and set it equal to 180. Okay, so I do end up getting 5x is equal to 65. If I divide by 5, x is equal to 13. Okay, then I just need to solve for y. Well, I know this angle right here is 65. So this angle must also be 65 since they're opposite. So I can set 2y equal to 65 to get 32.5. Okay, questions on those problems? Okay, so those ones had to do with your opposite angles, your opposite sides, and your consecutive angles. If you flip to the back, these ones have to do with some of those diagonal properties. Okay, so in number 5, again, we're solving for each variable. If I draw in each of my diagonals, they do intersect at that midpoint of each segment. So I can say this piece and this piece of that segment are congruent because that point of intersection is a midpoint. Same thing with 8 and 4y. Those pieces would be congruent since this is a parallelogram. So from here, I just have to set sides equal. So to find x, I can set 3x equal to 12. to get x is equal to 4. And then for y, since those pieces are also congruent, I can set 4y equal to 8 to get y is equal to 2. Okay, so again, this one has to do with that midpoint. Those diagonals bisect each other in a parallelogram. Okay, I want you to do number 6, and you can try number 7, but I'll go through number 7. So do number 6, try number 7, and then I'll go through them. Should be able to find x in number 7. Well, since this is your midpoint, so nothing's just like we had here. And then everything in the second midpoint, so all of this is all All right, so number 6. I know that where these diagonals intersect is a midpoint. So since I have this piece right here, it has to be congruent to this piece right here. So since it has 1 dash, that one also has 1 dash. Same thing here. Okay, bisect, since this one has 1 dash, this one has 1 dash. Okay, so that means each of these pieces inside this parallelogram are congruent, which means it's a rectangle, but we'll go over that when we get to rectangles. Anyways, to solve for each of these variables then, I can set 4x equal to 28 to get x is equal to 7, and 2y is equal to 28 to get y is equal to 14. Okay, then number 7. Okay, I said you could probably find what x is, but it'd be a little more challenging to find out what y is. So if I look at this triangle right here, it is a right triangle, okay, and I know each of these angles here are congruent, meaning they're what measure?
90.
Together they're 90, right? So each one would be 45. So I can set 3x equal to 45. Meaning x would have to equal 15. Now I need to solve for y. In this problem, it's not like number 6 where each of these pieces are congruent to each other, so you can't set 2y equal to 12. Okay, those aren't congruent. However, I can find this length right here in that right triangle to set equal to this length of 2y. This is a 45, 45, 90 triangle. It's a special right triangle. Okay? I have one of the legs. I need to find the hypotenuse. Okay? That's this right here on this pink sheet. Okay? I have to find the hypotenuse. To get that, I just take my leg, which is 12, multiply it by the square root of 2. So this length right here is 12 times the square root of 2. So now that I have that length, and I know that point of intersection is the midpoint right there, I can set 2y equal to 12 square roots of 2. From here, I just need to solve for y, so I'll divide both sides by 2 to get y is equal to 6 times the square root of 2. And I'm going to leave it like that. I don't believe you have any ones like that on your assignment, but I do want you to know that those special right triangle rules don't go away. Okay, any questions on 6 or 7? Okay, then the last part here, we're going to graph parallelograms. Okay, then we want to find the coordinates of intersection of the diagonals. Okay, so first, we want to graph each of these points. So if you haven't yet, graph points A, B, C, and D in number 8. Number 8. Oh. So I have A is at 3, 6. B is at 5, 8. C is at 3, negative 2. And D is at 1, negative 4. Oh, it's really hard to see. I'm sorry. Should have used a darker color. I should have. So here's my parallelogram. Now we want to find the coordinates, intersection of the diagonals. So if I draw in my diagonals here, okay, now with these problems, they're not always going to hit at a nice point. So if you remember to your properties of your diagonals, I said they bisect each other, meaning they hit at a midpoint. So what you can do is take 2 points or 2 vertices across from each other, like A and C here, and we can find the midpoint of those 2 points. So I'm going to use A and C. And again, your midpoint formula is x sub 1 plus x sub 2 over 2, y sub 1 plus y sub 2 over 2. And we're going to use those 2 coordinates, those vertices, opposite vertices, in that formula. So x sub 1 is 3, x sub 2 is 3 over 2, y sub 1 is 6, y sub 2 is negative 2 over 2. Okay, so I have 3 plus 3 is 6. 6 minus 2 is 4. So I end up with 3, 2 as my intersection point. So you can just find the midpoint of that one diagonal, and that would be your intersection point of both. Okay, questions on number 8? Okay, then do number 9 for me. All right, in number 9, I have each of my vertices plotted and I drew in the diagonals. For this one, you'll notice your diagonals don't meet at a perfect point. Okay, it's in the middle of one of those squares there. So again, I do want to use that midpoint formula of your opposite vertices. So I'm going to use A and C, but you could use D and B as well. Okay, it just has to be those opposite vertices because you want to find the midpoint of that line. So I can take -4 plus -1 divided by 2 and 3 plus -2 divided by 2. Okay, I end up getting -5/2 and 1/2. Now you could just leave it like in fractions like this, that would be fine. Okay, or you could put it into decimal form to get -2.5 and 0.5. Okay, again, these problems are for you to understand that it is a midpoint where those diagonals intersect of each line. Any questions on your properties of parallelograms?